Good morning everyone. Today I am going to discuss about chromatography. First of all, the definition. This word is derived from the Greek word which is composed of chroma and graphy. Chroma means color and graphy means to write. It literally means to write with color. Initially, chromatography was utilized to separate colored component mixtures such as chlorophyll. However, later it was applied to most other mixtures of chemicals, whether they were colored or not. Chromatography is an analytical technique that can be used for qualitative and quantitative analysis. It is a useful form of separation science that uses intermolecular forces to separate the components of a mixture according to their properties. Applications of chromatography. There are various applications in different fields. In case of pharmaceutical science, chromatography is used to identify molecules in drugs and measuring the purity of medicines. In environmental science, it is used to analyze water quality and gases in the air and their impact on the earth. In police work, it is also used to analyze various things such as breath analyzers and in drug detection. In case of forensic science and archaeology, it is used to analyze blood and hair samples. In biomedical research, it is utilized to analyze proteins in cancer research. And in case of food science, it is used to analyze the nutritional quality of the food and the food spoilage. There are mainly two phases of chromatography. One is mobile phase. It is a solvent or gaseous component that moves over or through the stationary phase. And stationary phase, it is either a solid with a high surface area or a liquid coated onto a solid support. Principle of chromatography. Components of the sample are more attracted either to the mobile or the stationary phase depending upon their intermolecular forces. This makes the components move at different rates and separate them. There are various key terms which is used in chromatography such as affinity. It is Affinity can be defined as components of a mixture are attracted via intermolecular force to the mobile or stationary phase. High affinity means they have strong interaction with the given phase. Adsorption. Components of the mixture adsorb onto the stationary phase from the mobile phase if they are attracted to or have an affinity for the stationary phase. Desorption. Components of the mixture desorb off the stationary phase into the mobile phase if they are attracted to or have an affinity for the mobile phase. There are various types of chromatography such as paper chromatography, thin layer chromatography, column chromatography. Column chromatography is further divided into gas chromatography and high performance liquid chromatography. First of all, we will discuss about paper chromatography. In this type, the stationary phase is a thin strip of absorbent paper which is cut to fit inside a container that holds the mobile phase. A pencil line is ruled across the bottom of the paper to mark where the sample will be placed, called as origin. Pen or ink should not be used to mark the origin because inks will spread and contaminate the sample. The sample is placed on the paper and standards of known identities also added to help identify the substances in the sample. The mobile phase is added to the container so that it sits below the origin line. The paper is then placed into the container and left to absorb the mobile phase. The sample travels up the piece of paper, separating into its components. Components having strong affinity for the stationary phase move slowly, hence separate earlier, and components having high affinity for the mobile phase move faster and hence separate later. When water is a mobile phase and paper is a stationary phase, any component of the sample that has whole or partial charges such as ionic or polar substances will have a higher affinity or attraction for the water mobile phase. These components move farther from the origin. This is because water and paper both are polar, but water is more polar than paper. Any component that experiences dispersion forces has a higher affinity for the stationary phase, hence not move as far from the origin. This is the diagrammatic representation of paper chromatography. Here the leaf chlorophyll content is separated into its various components, and these components are carotene, xanthophyll, chlorophyll A and chlorophyll B. Now retardation factor. What is retardation factor? Once the separation is completed, the resulting chromatogram is analyzed to identify the substances in the sample and to determine the purity of the sample. This is determined by calculating retardation factor of the substance. Retardation factor is the ratio of the distance moved by a substance to the distance moved by the solvent or mobile phase. Each atom, ion or molecule has a unique RF depending on the properties of the mobile and stationary phases. Increasing the polarity of the mobile phase increases its affinity to charged particles within the sample. This makes the substances move further up the paper. All retardation factor values must be expressed as a decimal and cannot be greater than or equal to 1. RF of 1 indicates the substance has not separated from the mobile phase and therefore the components cannot be identified. Next is thin layer chromatography. It works by the same principles as paper chromatography. Only difference that it makes the process more efficient in both ways, that is, it is faster as well as it is more sensitive. In TLC, the support for the stationary phase is a piece of glass or plastic coated with silica gel, aluminum oxide or cellulose. The coating is a thin layer spread on the surface of the plastic or glass, hence the name thin layer chromatography. The components of the mixture are separated as with paper chromatography according to their affinity for the mobile or stationary phase. TLC is not limited to colored compounds. Fluorescent TLC plates can be used under UV light to see the components of non-colored substances that would not otherwise be visible. This is the diagrammatic representation of thin layer chromatography. It is you can see a glass plate coated with the silica gel and it is placed inside a container. The mobile phase is present below the line of origin and components get separated as the mobile phase or the solvent get absorbed by the plate. There is another type of chromatography, two-dimensional chromatography. It can be in case of paper or thin layer. Sometimes a chromatography technique will not separate some components sufficiently within the sample. This is because the components interact the same amount with the mobile and stationary phases. Rather than repeating the analysis, chemist will rotate the chromatogram by 90 degree so that sample is on the bottom. They rule a new origin line and run the analysis again using a different mobile phase with different properties. This is the diagrammatic representation of two-dimensional thin layer chromatography. In the first image, you can see the components are not separated properly. So the chromatogram is rotated by 90 degree and a new line of origin is drawn, and the new mobile phase is used, new solvent is used, which then separates the components perfectly. Next type of chromatography is column chromatography. It is more advanced form of separation science than paper and thin layer chromatography. It uses the same basic principle, but the stationary phase is contained within a tube open at both ends. It is simplest form of column chromatography, uses a glass column similar to burette, which contains a stationary phase of aluminium oxide or silica. The stationary phase resembles finely ground sand. The stationary phase must be packed tightly to minimize pore spaces. Else, the sample will move too fast and will not interact with the stationary phase. Hence, less separation will occur. The mobile phase is poured into the top of the column and allowed to run slowly down through the stationary phase until it reaches the tap at the bottom. Once the column is soaked in the mobile phase, the sample is added to the top of the column and the tap at the bottom is opened. This allows the mobile phase to run through the column with the sample. The sample separates into its various components depending on their affinities for the mobile or stationary phase. Higher affinity for the mobile phase means that a component spends longer interaction with it. As the mobile phase flows through the column, the component moves with it and it is collected earlier. Different components of the mixture are collected in separate beakers as they elute from the column. Further techniques are used to identify and quantify them. It is the diagrammatic representation of column chromatography. You can see a glass burette which is open at both the ends. At the farther end, there is present a tap. The sample, when moves with the mobile phase, the components get separated and they are collected in different beakers according to their time of elution. Further, column chromatography is divided into gas chromatography and high performance liquid chromatography, which we also call as HPLC. Gas chromatography. The mobile phase in gas chromatography is an inert gas or carrier gas such as nitrogen. The sample is vaporized and injected into the mobile phase, which carries the sample through a very small diameter and a very long column containing the stationary phase. The stationary phase can be either a solid packed into the column or a liquid that coats the inside of the column. Both stationary phases must be able to withstand very high temperatures because the column is contained within an oven to ensure that the sample remains vaporized throughout the separation. The sample separates as each component interacts with the stationary phase. There is no attraction to the mobile phase because it is an inert gas. Its purpose is to move the sample through the column. The components with a low affinity for the stationary phase elute from the column first. They are not retained on the column for long. The components with a high affinity for the stationary phase are retained in the column for a longer time period. Each component forms a peak in the chromatogram as it elutes retention time. What is retention time? The time that it takes a sample to move through the column from injection to detection stage is called the retention time, or it is the time that each component is retained by the column. It indicates the amount of interaction that has occurred between each component of the sample and the stationary phase. This is the diagrammatic representation of gas chromatography. There is a cylinder containing the carrier gas. In our case, I told you the inert gas nitrogen is used. There is a chromatography column where the separation of components occur. As they get separated, the detector detects the component and a peak is drawn according to the component which is detected, which get stored in the computer. Further, another type of column chromatography is high performance liquid chromatography, which is also called as HPLC. It operates on the same principles as other chromatographic techniques. It uses liquid or aqueous mobile phase, which is pumped through an instrument. The sample is injected and the mobile phase moves the sample through the column at a specified flow rate. This flow rate can be altered to pump the mobile phase with the sample through faster or slower. It is very similar to the column in chromatography, but particles are much smaller and more tightly packed. As the sample moves through the column, it interacts with both the mobile and stationary phases to separate into various components. The detector recognizes the components as they elute from the column and generates a chromatogram similar to that generated by the gas chromatography. The temperature of the column can be altered, but not as much as with the gas chromatograph because the column is made of plastic which melts at high temperature. This is the diagrammatic representation of HPLC. The mobile phase is pumped to the separation column where stationary phase is present. The mobile phase separates the mixture into its components and the detector detects the components when they are eluted from the column and a chromatogram is drawn in the computer. Interpretation. Both types of chromatograms are analyzed in the same way. The peaks are identified by running standards under identical conditions and analyzing retention times. Concentration is determined by using a set of standards of accurately known concentration, plotting a calibration curve, and measuring an unknown sample on the calibration curve. Advantages of column chromatography. It has the advantage of measuring the components of a sample quantitatively. This is done by measuring the height of the peak or the area of the peak. Most of the chromatographs are computerized and programmed to complete these calculations. A computerized gas chromatography system usually measures peak area rather than height. So, here we finish our topic chromatography. Thank you very much.